All right, chemistry class, we're on to day 35. It's Tuesday, April the 14th. So we're going to cover the atom today. So how was atomic theory developed? Well, first we start with J.J. Thomson. So in about 1897, physicist J.J. Thomson discovered the electron. So what he did is he used what's called the cathode ray tube. It is basically a machine gun for electrons, and it fires them from a negative end called a cathode to a positive end called an anode. Remember, electrons are negatively charged, so they're repelled by the negative end and they're attracted to the positive end. And it's just a big tube with those two ends on them. So the positively charged plate attracts the electrons there. And this creates a visible stream of electrons. You can actually see electrons. There's mass numbers of them, but you can go ahead and see the electrons there. And then a magnet causes the negative electrons to change directions. And by knowing the charge or the mass of the electrons and seeing how quickly they bend, how easily they bend to that magnet, will tell you both the charge on the electrons and what their mass is. In other words, more massive things don't turn quite as quickly, just like a big truck can't turn as quickly as a motorcycle. And so this allows the physicist or the chemist to determine what the mass of the electrons is. So in 1904, J.J. Thomson proposed a model of the atom that included electrons. So he believed an atom was a positively charged ball that contained small negative electrons, so that the overall atom had no net charge. He just believed that the rest of the atom was this big blob that was a positively charged blob. So you put these little negative electrons in there into this positively charged blob and it becomes neutral. The model was known as the Plum pudding model of the atom because it was soft. It was a soft solid with chunks of electrons. So there's actually a picture of English plum pudding. It's not what we would think in the United States of being pudding. It's more of like a bready kind of a cake. In 1911, as a student of Thomson at the University of Manchester, Ernest Rutherford demonstrated two things. Should be two things. An atom has a solid nucleus center, but that most of the atom was empty space. So Rutherford, what he did was he shot positive particles called alpha particles. And alpha particle, by the way, is 2 protons and 2 neutrons. It's the equivalent of the nucleus of a helium atom. And he shot that at a thin sheet of gold foil. Now, if Thomson had been correct, the alpha particles would have shown a small deflection or would have just gone straight through the gold foil. But in fact, most showed no deflection, and some bounced back. And this indicated that there was a solid nucleus surrounded by empty space. He was surprised by this. He likened it to firing a gun at a piece of Kleenex or a piece of tissue and having the bullet bounce back. He did not expect that to happen. So he had to conclude that there was something very solid inside of that gold foil, and that was the nucleus of the gold. So this is kind of a close-up. If you assume that purple image there is the gold nucleus, and the little brown pellets are the alpha particles, then most of them would just go right past the nucleus. Some of them that came close to the nucleus would be bent because they have a positive charge and they would be repelled by the positive charge in the nucleus, so they would kind of bend and curve. But occasionally, one in a few thousand would actually bounce straight back or pretty close to straight back. So most alpha particles miss the nucleus, some are deflected, and a few hit directly and bounce back. In the late 1800s, scientists noticed that positive charges were traveling in the opposite direction in Thomson's cathode ray tube, and these were named protons. In 1932, English physicist James Chadwick discovered a particle that had the same mass as a proton, but no electrical charge. This particle was called the neutron. So protons and neutrons each weigh about 1,820 times more than an electron. So just a little illustration above San Diego Stadium. If you put the nucleus of a helium atom floating above the middle of Qualcomm, used to be called Qualcomm Stadium, right there, so 2 protons, 2 neutrons. Then the electrons would be buzzing around in the upper deck. And in fact, really they would even be farther away than that. So most of the volume of an atom is made up of empty space. Okay, what is an isotope? An isotope is an atom of the same element, but with a different number of neutrons. So we learned that a typical lithium atom, well, we haven't really learned that yet, but you're going to find it out now if you look at your periodic table. The typical lithium atom has 4 neutrons, but occasionally we come across a lithium atom with only 3 neutrons. So the notation for an isotope is as follows. You write the atomic symbol, and at the bottom is the atomic number. That doesn't change. Lithium has to have 3 protons. We're going to get into that in a moment, that definition. The top number, though, is the atomic mass, or the mass number, and that can be different in an isotope. So for a normal lithium atom, most lithium atoms have 4 neutrons. So 3 protons plus 4 neutrons is a total of 7 for the mass number. Occasionally you find a lithium, though, that only has 3 neutrons. So 3 protons plus 3 neutrons will give you a mass number of 6. So that's how you distinguish between 2 isotopes. So notice that the atomic mass is on the top, the atomic number is on the bottom, and that's the opposite of the periodic table, as we're going to see soon. Okay, so what's an ion? An ion of an element is an atom that has a different number of electrons than protons. So here we have on the left an electrically neutral normal lithium atom. It has the same number of protons as electrons, so its charge is balanced. And there you see it. That's the way a normal lithium atom, what it would look like. On the right, though, you see that the one on the right has lost that second orbital electron. It's disappeared. It's gone. We're going to find out why that happens and talk about that in the next week. But what you end up with then is just one orbital around that lithium with 2 electrons. So you see it has 3 protons and 2 electrons. So it has more positive charges than negative charges. That means it has, overall, it has a positive charge to it, and that's called an ion. So what is an anion? An anion is an atom that has more electrons than protons. So if we look at this fluorine atom is an example of an anion. It has 1 more electron than proton. You can count them. There's 10 of the blue dots and there's 9 of the pink dots. So it has 1 more electron than proton. So an anion has a negative charge. And the little mnemonic, the little memory device is that this grumpy guy is a negative ant-ion. So negative is an anion, and you're going to contrast that in a moment with the other. So the example we saw of lithium a couple slides back, a cation is an atom that has more protons than electrons. So this lithium atom is an example of a cation. It has a positive charge because it has more pluses than minuses, so it has a net positive charge to it. So the mnemonic for that is, this dude is a positive cat. The big smiling cat is positive, so positive is the cation. So what is an atomic mass unit? So they needed to develop some system to determine what's the mass or weight, if you want to think of it as that, of things really light, such as atoms. So we can think of an atomic mass unit as the mass of a single proton or a single neutron. Protons and neutrons weigh just about the same. Neutrons are actually slightly heavier, but we're not going to concern ourselves with that. We're going to treat them as though they weigh exactly the same. And that weight is called an atomic mass unit. Since the atomic mass of each proton and neutron is 1, an element's atomic mass tells you how many total protons and neutrons one atom has. So let's go over an entry on the periodic table, and we're going to use hydrogen as our example, and understand what the 4 main parts of that entry. So if you look at a periodic table, you see these 4 things. So atomic number. This is the number of protons that an element has. It is also the number of electrons that an element has if it's electrically neutral. So when all atoms are born, they have the same number of protons as electrons, and since they're charge balanced, same number of pluses as minuses, they're said to be electrically neutral. So that number on the top, called the atomic number, tells you how many protons that an atom of a particular element has. The key point is the number of protons is what determines an element's identity. For example, hydrogen must have 1 proton. Lithium, for example, must have 3 protons. Lithium could gain or lose electrons and still be lithium. It could gain or lose a neutron and still be lithium, but it must have 3 protons to be lithium. Hydrogen must have 1 proton to be hydrogen. All right, atomic symbol, and that's simply the abbreviation, and those are important to know because those are what you're going to write when you write chemical compounds or chemical reactions, is you're going to use the atomic symbols. So that is, H is the atomic symbol for hydrogen. And then the name. Some periodic tables don't put the name. I think they all should, but some don't. But the one that you have does have the name in that box. And finally, down at the bottom is the atomic mass. That's the average mass or weight of the element. What does that mean, the average mass or weight? Well, the vast majority of hydrogen atoms have exactly 1 proton. We don't count the mass of electrons. They're considered so small that that's not even counted. But the average hydrogen has 1 proton. That means it has an atomic mass of 1. Occasionally, though, very rarely, you'll find a hydrogen with a proton and a neutron, or even more rare, a proton and 2 neutrons. So that means there's a few that are heavier than 1. So when you take the average of all of them, you actually end up with slightly more than 1 for the atomic mass of a hydrogen atom. Okay, so what does electrically neutral mean? Electrically neutral means that an atom has the same number of protons, positive charges, as electrons, negative charges. The same number of positive and negative charges mean that the atom is balanced electrically. We use the term electrically neutral to indicate that the atom has no net electrical charge. All right, so that takes care of our lecture for day 35 and Tuesday, April the 14th. So go ahead and answer the questions. There's also another video to watch and a few questions to answer with that. So we'll see you on Wednesday.